Hello.
Hello, I guess the last meeting just ended, so still waiting a couple minutes for folks to join.
Yeah.
We should probably set all our meetings to be 55 minutes because we always go 5 minutes over.
That's
and
one.
even then, they would take those 5 minutes and go another 5 minutes over.
Yes, indeed. Yeah.
Hello, everyone. This is Bala.
Bala.
Well,
Hey, I think I'm 1 hour off in my calendars. My calendar still 1 hour off. So I joined the architecture
yeah,
meeting.
I think the really big confusion comes from there's one from LF and there's one from John. The John ones are taken out, but then some people actually explicitly set the one that John sent out. So it's still on my, for example, it's still on my Google calendar because when at one point it was probably not John, it's a program manager who did it. It disappeared, and because of that, I initiated the effort of putting it on my calendar directly, manually, explicitly, and then so that item still exists on a time which is an hour later. So
okay, so this is the new timing now, right? For both meetings.
yeah, I think for both this and automations, it's like there's some rumblings like and on whether or not we should like really move it back into more of a 9 a.m. Actually, in my case, 10 a.m. Pacific time. People reference using Pacific, but
I did get feedback from people in the other time zones in Europe that would prefer the earlier hour. So I know 8 a.m. is pretty early in the Pacific, but I guess that's where we are now.
Yeah.
Yeah, but the thing is, it's a bit confusing with the invites in the calendar. It was once the DST started, I think it's confusing all around.
You have to delete the entries, in my view, or at least that's what I did.
yeah.
I just said, okay, these are the ones, and all the rest doesn't matter.
Okay, so now it's so both the meetings starts an hour earlier, right?
And even all meetings, even so SIG Release, SIG Automation, and
yeah,
all three. And I think even the TSC.
I'm not even sure about TSC because TSC hasn't happened since we actually changed.
Let me check my calendar.
Is it true with SIG Automation too?
Yeah, that's true.
Yes,
yeah, it's 8 a.m. Pacific now.
Let me change all that.
Every Wednesday, yeah.
TSC, in my view, is still in the original timing, till 9, at least in my calendar. I'm not sure, but that's how it shows in my calendar. See, there was some confusion because at some point, I think there was a request to move all the meetings 1 hour later. Then there was a reply that we didn't want it, but it happened.
Yeah.
And so, but okay.
I think when we said we didn't want it, we didn't know it was very impactful for a lot of Pacific people.
Yeah.
Yeah. Okay.
I think we didn't want it because it was going to change in the US for like 2 weeks later, right? So I think we didn't want. I think there was some European.
So the LF automatically changed them, and then Kirk Taylor actually asked whether or not we want to move it back to the original time. And then we said, well, let's keep it for now. And then everyone get confused, and then so we're contemplating, and then as Tal said, probably it's better for the Europe folks at the current time. Any case, a lot of the states, not all of them, for next year it would be one time zone. It wouldn't go into standard time.
So it's not been approved yet, actually.
The state. Yeah. But
I
California is not one of them. So
the House of Representatives have to approve or something, right?
it hasn't been approved yet. So it's kind of interesting. I know it's 12 states or something like that, but not we're not part of it. Anyway, so it's 7:10 already. So no, actually like 9:10. I'm actually in Hawaii right now. So I mean it's 7:10 a.m. Yeah, I'm actually on vacation today.
Okay.
That's why I joined the last meeting like 30 minutes late. And missed another like real meeting too. But anyway, so this is the Nephew SIG Release Meetings for November 28th, 2002. Thank you for participating. I guess, I mean, the major agenda really is, talking about how we evolved what we did actually on One Summit as our core CI and test tools. But then Vim has something else, so I can just let Vim go ahead and do your thing.
Yeah, so I mean, first of all, I don't know whether I stepped on anyone's toes, but what I did is I created an Ansible. I just shared it to the Slack channel. See, I wanted to proceed with the POC, which is what I did. Huh? So the good thing right now, I'll share my screen. Yeah, yes, I share my screen. Oh my God. Cannot share my screen. I hope I can share my screen. What is this? What does it say? Desktop share.
Does it make sense?
Opens.
So they have already upgrade to the latest version, but their configuration is still wrong.
This is about Zoom.
I try to understand what the root cause for this.
Well, they checked
I think she's on a different meeting. I think
By the way,
maybe she
I see.
forgot to mute
Oh,
herself.
okay.
I have to quit and reopen, so I'll be back right away.
Go ahead.
One moment. Yeah, one moment.
Go ahead.
Yeah, we
The
can listen
person
to
who
the
owns the
meeting.
meeting, I think, should be able to mute people that aren't muting
Yeah, I mean,
themselves.
I'm not. No one is the host, but I think
Yeah, even last time I tried to mute Tina.
everyone is non-host.
Because by default, Zoom opens as a unmuted. Most other actually mute you by default. Yeah.
Okay,
So I simply need to go and read the
Hello, Tina.
issue log on how to fix it by pretty simple configuration issues.
okay. So because before that, the CentOS there's no such issue.
So
Then
the
they
Linux
switch
Foundation
to
made this in the
Ubuntu, so
recorded.
the issue appear. They need to fix
He
it.
doesn't know.
Is that right?
Yeah, they
Just hope
don't.
no
they're-
company information comes out on this call.
Yeah.
Is it correct understanding? Yeah.
Yes.
Okay, good.
Let me see.
All right. Okay, good. So another question for you is the PSA white paper. What's the status now?
Is Tina?
Hello, Tina.
He has us on mute.
Smart.
Probably.
I'm
But
sorry,
how-
I'm muted.
Okay.
All right.
Yeah, go ahead, man.
So I progressed the POC. So the good news is that UPF is running, but it doesn't do anything at the moment. Now
I replied to your thing, so yeah, I had the same problem. Yeah.
Yeah,
the
sure.
privilege problem.
But indeed, before during the POC, it was not even coming up because Multus was
Oh, I
not happy, right?
Mhm.
So I think I fixed that. Now that's one.
yeah.
So the reason why I wanted to have the session is, and it's good that Bala and Ravi are on the call, because I was doing some reverse engineering on the scripts to basically replicate the lab that was set up. And I created an Ansible playbook environment with some documentation, which I shared on the link, I thought. Do you see this?
Yeah.
You see my screen?
Yeah.
I don't know whether I stepped on anyone's toes, but I built it for myself just to be able to replicate the environment. So this is an Ansible playbook, which basically installs the whole POC again with some documentation. If we want to reuse it, I'm fine. If you want to throw it in the bin, it's also fine. I
No, you
just
should
shared
use
it, what I use, because what I saw myself, I did reverse engineering on the scripts, and that's how I came to this. And so it allowed me to respin it. But I then said, okay, let me document all of it so that people can replicate it, because at the moment we build those environments, right? And then I said, okay, there's probably people who want to replicate an environment in their own personal labs, and then they are able to do so. So that's what this is. Now, so we can have a look at it. The plan, we can discuss it as well if you want, but it's basically Ansible completely, and I install it remote. So that's probably a debate whether you want to do it like that. It's still Ubuntu, so we can also change it to RHEL or to any other Linux distribution. So if you want to use this as a platform, we can make it more generic and use it in various different environments such that people can leverage it. But I just said, okay, let me share what I did. Then people can use it. So, but I also documented it. So you have to create an inventory file and then, run some playbooks. Basically, there are some people who are trying it out. So it hasn't really, I assume there are still some problems with it, but I'm using it personally to replicate what I did.
Cool.
Okay.
So, I mean, you were not stepping on, but basically we needed this. And I was going to actually pull in Sandeep's and whatever was there from Victor's. And it seems like you already have it, which is great. If you open a PR, maybe the discussion can happen in the PR.
Okay, yeah, I will do that. I just wanted to share, but that was my baseline to discuss what I'm going to present next, right? Which is basically the way that we did the connectivity. So what I saw, and this is where the problem came when originally the UPF was not coming up, right? What I took this picture or this diagram from some of the README files that I saw. And one of the things that I saw, and I'm not sure whether it's 100% correct, but at the moment we have a single, so if you create a kind cluster, it creates a virtual Ethernet pair to a Docker bridge, typically, or it can be a Podman bridge, depending on the environment you run. But it's a single interface. And I believe that for the reality of how people deploy a 5G core, this is not realistic. So in other words, what I'm trying to get to is what I've seen in more scenarios is that if you take a cluster, what I'm trying to represent here is that Ethernet 0 is kind of where the default Docker bridge is connected. So for me, this is the default CNI. I call this the default CNI interface. And that's used typically to run the default CNI. But if you really use Multus networks, they typically happen through a dedicated NIC onto that environment. So what I'm trying to represent here is a way that within the kind cluster, we actually are able to attach those Multus networks to a dedicated interface that would be consumed by Multus. And of course, I created here Ethernet 1 and Ethernet 2. It can be Ethernet 1 with VLANs as well. So it shouldn't really matter, right? And so that's basically what I did at the moment. So if you look to my kind cluster, if you connect to the kind cluster, and if I do IP, so this is one of the kind cluster, you see that I injected an Ethernet 1 interface to represent that Multus network. I created just one just to try it out. And then in the CRDs, I referenced this Ethernet 1 in the Multus network attachment definition. And this is how that resolution now succeeded as a result of plugging in that Ethernet 1 and ensuring that the configuration was aligned. And as a result, the Multus network attachment definition that we were rendering were aligned with what we put into the configuration and stuff like that. And that allowed us to connect. So at the moment, I only injected one. I could inject multiple, as many as I want, basically, right? And
when are you using Weave? Like
no.
Okay.
This is purely what I did is purely we have a tool which I will introduce in a bit, which is Container Lab, which does that. So what we actually do is we inject a V pair into the kind cluster. And that's how we actually build topologies for networking. So Container Lab is a tool. What it does, it actually builds virtual topology. So container labs, so basically container-based images, and we build labs with it. So let me share with you. So this is so it's open source project. So what this is, for example, leaf-spine fabric. You see all these wires here. They are all implemented through V pairs, and they are injected into these containers dynamically. And by doing so, you create like a virtual interface, or actually a virtual wire in between those two containers. And that's how we build virtual labs of any topology you can imagine.
So okay? I don't want to say that we shouldn't use this, but I see Victor isn't here, but I have a solution that doesn't have any requirements. That's like very, very simple, and it does exactly that. You can create as many extra networks as you want. And in my example, I'm using rootless podmen, so there's no need for sudo or root or anything like that. I don't know if you're interested in use this. This obviously looks more flexible, but I'm sharing the link to my repository here. It's very, very trivial, I think, to set up, and it might be simpler than this.
So the reason why I will propose this is the following: is that we can now also, for example, I think in one of the things that Steven was mentioning, we want BGP, we want routing protocols to the network stack and stuff like that. All of that is possible right now, and we can build any topology in a declarative way, in essence, right? So, for example, just to show you what I did as a topology that I'm consuming, it's a very simple one. But if you look what we do in Container Lab, is we basically build a topology file. So we say, here is a bunch of nodes, and here is a bunch of links. And it basically, by just do CLab deploy this thing, it basically automatically wires up everything, and you can build any topology that you want. So it's also a very declarative way, and we have various support of lots of vendors. So you see, if you look to the list of vendors that are using this thing, we have almost any vendor on the planet that you have here. So even if you look to the vendor list, we have Sonic is even on it. So we have various people. So if you look to the kind list, so these are all so you have Dell, Microtech, Palo Alto. You see, it's not even limited to networking vendors, right? So you see, this is actually the tool that is being used to actually wire up labs these days. And so what is the advantage, in my view, that you get? I'm not familiar with what you have, Tal, but for example, if you want, so one of the things that we want eventually is to run BGP to a networking device here. We can do that. Out of the box, we don't have to do anything else. So this is, for example, the topology that I built. I only put 2 clusters. So in reality, I have 4, right? But basically, what happens is that I connected this kind cluster to, this is a router device, so actually emulating a real routing environment. So we can run BGP to it, we can run OSPF to it, we can run ISIS to it, we can run anything. We can create multiple of these, let's say, functions. So in other words, we could have a lab which this is a one router and this is another one router on the other side, and interconnect them in one way or another with a virtual topology. All of these things are possible by just creating this topology file.
So does it actually deploy a router, an open source router component?
Yes, yeah, it does. Yeah. So for example, here I created, so this is an open, this is a free as a Linux router that we have, so it deploys it as well. Yeah. So if you look to the command that I had to use to invoke it, it's CLab new deploy -t. It will not run right now because I have it already running. If I do this, this would, yeah. So it has to run in sudo, by the way, because we create the V pairs, but at the moment it's already running. But it basically, yeah, it wires up the whole thing, spins up the containers, does the whole 9 yards. You could even give it config if you want.
And the kind clusters could be on, I guess, multiple virtual machines or places.
Yes. Yeah, correct. Yeah. Yeah, correct. Yeah, they can be multiple virtual machines. Yeah.
Wow, that's very impressive.
Yeah. So what I'm proposing is that we would leverage and use that, because we can then build any topology, if you will. I just created something very simple. So I created here a switch or a router connected to these 4 kinds clusters. At the moment, the kind clusters are spun up separately from the container lab. So in other words, what I'm doing is so at the moment, it is assumed that these kind clusters are created. I have asked for a PR, so there's a PR on Container Lab that also spins up the kind clusters, right? So in which case you basically have one tool that does it all, but it's not yet available. So there's someone working on it. At the moment, you have to spin up the kind clusters independent of it. But for example, yeah, so what I did into the lab is with this configuration, what you have is you have a kind cluster. So these are the 4 that we deployed in our lab. If you say there are 5 or 6 or 2, doesn't really matter. And here you say these are the interfaces that interconnect them. And so I injected here, so I put here Ethernet 1. So what this tool does, it injects Ethernet 1 interface, as you saw. And then I wired it up to this router on this interface, right? So if you look to the router interface, Docker exec. It also works with Podman, by the way. So there is no restriction there. If you go to bash, if you go srcli and you do info from what is it? Network instance from network from interface. What was it again? From state, from running network instance. Yeah, so I created here the sample VPC network. If you want to show the routing table of this device, show network instance, sorry, VPC, yeah, it does VXLAN and stuff like that. So yeah, what am I doing? Yeah, sample VPC, routing table. So you see here, these are all the networks that were in the IPAM system aligned with the UPF. So these were configured on the device. If you want to run BGP, you can run BGP. If you want to run anything else, you can do so as well. But it allows us to build a very flexible and yeah, a realistic way on how people deploy these clusters. So any questions or comments or feedback?
I think definitely for things related to functional tests and running them, this is useful. And for whatever we already have for the workshop, also seems like this can be the enhanced way of using this. Do we need this for all scenarios? I mean, I know this actually will be handy for all those, like, functional tests and trying out all the stuff.
Yeah, so for example, what I'm doing at the moment, yeah, so, okay, what I'm doing also, by the way, it's very lightweight. So for example, as a Linux container that I'm using here is 2 vCPUs and 2 gig of RAM. That's it. Okay. To run this. To run all the rest, it's just a tool that you run it once, and what it does, it creates V pairs between all the components that you set. So basically it doesn't consume any CPU, because once it's deployed, it's there. It doesn't do anything with it, right?
How many CPUs did you say? 2 CPUs.
For the router, it's 2 virtual CPUs and 2 gig of RAM.
For this entire VM where the workshop VM is hosted?
At the moment, what I deployed it on is 8 virtual CPUs and 32 gig of RAM, but I'm pretty sure that I can. Yeah, So, but I'm pretty sure I can lower way more than that with this environment that I have at the moment.
Okay, because when we tried, the 32 gig RAM was the minimum required in order to bring up 4 kind clusters. So we tried 16 also, 16 RAM, 16 GB RAM. We didn't, only 3 clusters showed up. So 32 gig RAM
because there was
the minimum for 4 kind clusters at least.
One of the issues that I saw, and I think it was in one of the scripts, is that you increase some of the system limits
Yes,
for the file descriptors.
I notify,
right?
yes,
Yeah.
I notify watchers.
And that was the one that also that I was bugged, I was stopped upon. So I added that, and then I had no issue. But I haven't tried to lower scale at the moment, so I cannot say. But if you look to what I'm consuming at the moment, that's the load that I have. So I would be surprised if I cannot scale lower than this.
Kind is very lightweight.
Yes, yeah, correct. So
a quick question. So Container Lab only installs Kind, or could it also support other distributions of Kubernetes?
So what Container Lab does, it basically wires things up, right? So in other words, it doesn't focus on the installation of the container of the Kind cluster. What I saw is that at the moment what we are doing is, if there is a container running, right, or it can also connect to a bridge, by the way. So if you look to so we have here a Linux container or Linux bridge support or OVS, right? So you can connect to any of these. So if your cluster is connected to any of these or is installed by any of these, it can connect to it. You see?
Okay, I see. So what you would do is first use Container Lab to set up your machines with the networking, and then install Kind to use it, actually.
Yeah, the other way around, I think, because right now is we inject the interface into the Kind cluster, right? So what I'm doing at the moment is I spin up my Kind clusters as regular, and then I inject the interface. So by specifying the interface, so this topology that I showed you, what it does, it actually, you see here, so this is a management control plane container. So if you do Docker PS, you see here, this is the name, right? And it says, this is the interface that you plug to it. So what it does, it basically looks for this container that it exists, and it knows it because it has a Kind external container. So that's how it searches for it, and then it injects from the moment it finds it. If it would not find it, it would basically create send an error to say, and it proceeds, right? So, but it says I cannot fulfill the complete thing.
I see. So you first create your containers and then wire them together.
Correct.
Could you show maybe the Kind cluster config too, or how you install it?
At the moment, the Kind cluster configuration, where is my method deployment, the playbook? Oh, it's in a roll. So, Kind tasks. Wait, no, I think it's in deploy cluster. This is the installation cluster deploy. This deploy tasks. Yeah, I think I can show you the file. Probably it's better because that's the file that I use. H1 cluster config. So that's what is in the Kind cluster. There's a cluster config.
Okay, and
So
then so then when you create the network attachment definitions, you also need the same CIDRs that you injected, right? You need that information as well.
Yeah, so what I'm doing at the moment, so this Ethernet, so what I'm doing, if you look to the Ansible playbooks, what they do is the following, is that I am even right now in my, I don't think I have pushed that upstream yet, but so I have this Ethernet 1 interface that I inject. I ensure that it's also in the cluster context. So if you look, if I do kubectl -- kube config, for example, now that's on the management cluster. So that's management cluster, get cluster context, I think. Okay, cool.
So which CNI actually are you using for the network
Guy-
attachment conditions?
Kindnet?
Mac VLAN.
MacVLAN. Okay.
Yeah.
Okay.
So you're not disabling the
think-
default CNI?
No, it's the regular kind, so I don't do anything. It's KindNet in the CNI
Kindnet.
plugin.
Okay, that's
Yeah.
what Kindnet.
So it's I don't. What am I doing wrong?
Did you want to get network attachment definitions, or
Wait.
you forgot the management cluster config?
No. So what I'm doing is wait. So if I look to the network attachment definition, H1 network attachments. Oh, sorry. Get network attachment definition minus add UPF minus YAML. So that's the one that I'm using, right? So basically there is master Ethernet 1, right? So that's the Ethernet 1 interface. These are the IPAM, and then the type is Mac VLAN, right? And if you look to
You actually fully define almost all the fields already on the NAD.
yes, yeah.
Yeah, all the addresses and gateways are sent.
Yeah. So,
And if you
so
look,
that CIDR that we saw, that's what you set up with Container Lab, right?
What I did with
004.
No, what I did with Container Lab is I just plugged in Ethernet 1 interface to the Container Lab, but the network attachment definition that was used is also using these Ethernet 1. So the way and that we do by in the NF deployment. So first, here you see the CNI. So it's just KindNet. So it's the standard CNI. We don't have to change anything here, right? So the Kind cluster is using the standard CNI. If you want to change it, you can change it. It doesn't matter, but it works also with the standard CNI.
Yeah, that's the network used for kind. Yeah, default kind. So in
the default
clusters, it uses that for your ETH0s, I believe. Yeah.
Correct. So for the default CNI so this interface is using a regular CNI, and then here I'm using at the moment Mac VLAN, but you can use IP VLAN. You can use SRIV, probably
No,
not.
so you're creating two additional physical quote unquote
yes.
interfaces onto
yes.
the kind node, basically, right?
Correct, and which for me is a more real life representation of how people consume it.
Right.
Because if you look to a physical server, those Multus interfaces are typically a dedicated interface onto a NIC anyhow. It's a dedicated NIC on a server.
Mm-hmm.
So I'm replicating.
But then your workload, in this case UPF,
yes.
how many interfaces they need is unknown at the moment you created the nodes.
That's correct, yeah. But so what you do on a kind cluster, in a real life environment, you typically say, okay, these are the amount of networks that I have, because normally what you have is you have either two pairs of extra NICs or one, right? One or two, sometimes three. And then you have VLANs typically on them. So what is a realistic scenario, in my view, is not what I presented here, right? Because so this would be Ethernet 1 with VLAN 1, VLAN 2. That would be realistic. So Container Lab basically only injects Ethernet 1, and that's it. Because you should see it as should compare it to the physical world. What Container Lab does, it's the virtual wiring, similar to how a physical server would be wired up, right? And then you typically consume it in the case of Multus, typically through VLANs.
Right. So it's Mac VLAN CNI. So it probably takes the IP address of the physical interface at that moment.
No. So what happens right now? So if you look to where we are at, so on the network side, I configured the IP address based on how the IPAM is set up, right? So if you saw here on the Linux, what I did is I created. So if you do show interface, so I created 3 networks. Basically, yeah, it shows only one at the moment, but I created 3 networks: 172.10, and so wait. No, they're actually here. You see, I created these 3 networks, and one is 4N4, one is 4N3, one 4N4, and one 4N6, basically, right?
So that's what I meant when you have the IP address range in the network attachment.
So UPF for UPF one interface, you take on one IP address off of the 172.1.0.0.1
Correct.
network.
Correct. So if you look to the network attachment definition, it got assigned 4 of that subnet through our pipeline that we did. So when we instantiated the UPF during that pipeline that we had on the management cluster, right? What happened is that the UPF got instantiated. It says, okay, I need to deploy on this cluster. In what I wanted to show before is that if you look to the management cluster, what we have is get cluster context, I think it's called. In cluster there's a cluster context of each cluster, which basically says use MAC VLAN and Ethernet 1. So that's basically what how the management cluster was set up. So at the moment, this is statically defined, but our goal is to discover this through a discovery tool. Right? But at the moment, what we did, when we created on the management cluster, we created 3 clusters, right?
Yeah, well, we kind of rushed it during the one summit. Obviously, the CNI type information comes from the vendor, not from the cluster. So.
No. But wait a minute. So the resolution of how we got to the network attachment definition was through this pipeline, right? So basically,
so getting there is correct, but then the information sources is actually kind of all over the place. It's a kind of like we kind of hack it such that it's just one source, but then it's actually coming from multiple different sources. The CNI types should come from network function vendors, and then the master interfaces should come from whoever the cluster admin is, basically, right? But anyway, so
wait, no. Yeah. So what we did is the following, Stephen, right? So what we basically said is that the philosophy was the following: when you discover a cluster, the cluster will be set up with a certain certain CNI types, right? And we basically said there's only one for the time being, which is MAC VLAN and Ethernet 1, right? And so when we instantiated the UPF, that topology file, during that pipeline, we took that information that was configured, which was supposed to be discovered, but we basically, it's not hard-coded. We actually configured, this is a CR that we put into the system, which was picked up by the UPF deployment pipeline. And that's how this was used as input to basically represent the network attachment definition.
Right. No. So for one summit, I don't disagree with that. The idea when I did my demo, or actually earlier, was that the MAC VLAN part comes from the vendor. So they will make a request of saying that I need MAC VLAN because they know what kind of CNI they need. And then if infrastructure doesn't support it, then obviously you don't schedule it. But then if it does, then it agrees. But anyway, so that's beyond the point. But then that's more like a SIG2 thing. That was the idea at the time. Yeah.
So just to clarify a question about the IP addresses again. So we can, because it's MAC VLAN, it's level 2. So we can really choose any CIDR ranges we want, right? They'll be routed there. But if if we use Container Lab to do a multi-cluster with routing, then we do have to use the IP address that we're actually routing, right? So we do have to set those in advance. Okay, good.
Wait, and there's 2 ways. There's 2 ways to do it. There's one is you can actually use in Container Lab. You have a startup config that you can put, right, which does that for you. Or you can also Container Lab, for example, the router that I'm using supports full YANG. It's a full YANG based router, so you could actually, if we go to the networking side or the transport side, we could actually use this to basically provision it through a CRD. You see?
Okay, so you could actually add those dynamically if you want a new CIDR range.
Yes. If you want, I can demo that as well. If you want, the configuration of the router I did manually, but I have a CRD that does it, so I can basically make a CRD that basically configures the whole router.
Yeah, this is really excellent because this is part of exactly the real life scenario you have where you need to configure a router. Using a netconf maybe or similar. So this
correct.
really help simulate that.
that was my goal. Is a little bit. It's not okay. I did Container Lab. I started it a couple of years. At the moment, someone else is running with it. But I really believe, not because I did it, but I really believe it will help us to build really realistic environments. And that was the reason why I jumped onto it. I first of all, my goal was to make the UPF deployment work. But then I saw if we can really do that, and it was actually very simple, that we build actually realistic environments. And then once we go to transport and other domains, we can actually very easily use the same environment to actually consume those elements.
No, this is really good. Yeah, I especially like when you show us that it can work with any of the bridge backend, right? With OVS bridge and all the other different bridges.
So is this also like an open source project? Container Lab?
Container Lab is fully open source. Yeah, fully open source. Lots of contributions. It's not a Slack channel. It's a Discord channel.
Okay.
But it's fully open. But you see here, these are all the vendors that already have implemented this thing, and yeah.
So in this case, can you also pick up something like a SRIOV, NIC and stuff? Can you specify it at that level?
See, SRIOV for me doesn't really matter.
That's the hardware dependencies, right?
Mm-hmm.
Yeah.
Yes, yeah. So Container Lab is focused on the wiring, right? So it's virtual wiring. Mm. So of course we also support the bridge, right? So because what you sometimes see, what people have been using this for is, okay, they spin up a virtual environment, but then they want to have a test tool which was physical. But you see in the meantime, there is Keysight of Ixia, so there is basically even testing equipment vendors that are being used to actually emulate. So there is emulators here, like there's security vendors over there. So it's really used to build like these virtual labs, very easy, lightweight. People spin them up in their PCs. That's the whole reason why we build it.
Cool.
Also for SRIOV, it's more like a node resource. What Vim does is for the fabric resource. So if we ever get to a point where our nodes can support SRIOV, that's a different definition, probably.
Yes.
Not the wiring.
No, for Container Lab doesn't care about that, to be honest, but SRIOV typically is a hardware thing. So what that means is probably you have to connect it to a bridge, right? And as a result,
and it shows up as a NIC basically to the OS.
Yes, yeah, correct, yeah.
So do they have stable versions of this?
Yeah, this is a stable version. So this is basically, I used a regular version. So, and there is, I think I'm not doing it, but the guy that owns this right now, he's building a gazillion of labs topologies. So you can basically take this file if you want to have Cumulus Linux. So you basically connect it and it will be up and running. The only challenge that you sometimes have for some of the vendors, you need to have a license or you need to get, you need to click on the website. Some of the OSs are free. So for example, the one that I used, which is a Nokia one, it's a free one. So everybody can download it and use it. So Sonic would be the same, right? So in Sonic, you can basically consume it as well, right? So you see some of the OSs that are here can be used. So like Arista, you have to register yourself for Arista, then you download it and then it works, right? But for others, it's more free. So it depends on which one you use. It's more free than others.
No Core OS on the list.
Core OS is you mean Core OS as a router?
Well, no, for installing OpenShift.
OS?
Core OS is the basis for OpenShift.
Yes. But for us, it's just a Linux container TAL.
Okay, have you actually tested with Core OS?
I think
Core OS is very locked down, so it's sometimes hard to do.
Okay, I don't know. I have not. I don't know. What I do know, for example, Cilium uses Container Lab, for example, to test Cilium.
Okay.
So what is your point, Tal, there? Because Core OS is on the nodes, basically, if it's a VM or if it is actually a metal node, but the container itself usually is not Core OS.
Since the OS is immutable, I think that's where Tal is getting.
Yes, I don't know. Yeah. We inject because we inject a V pair, and the question is whether it's possible. I think that's your point, Tal, right?
Yeah, exactly. Yeah.
Yeah, well,
I
you
don't
have
know.
to create these NICs at the operating system level. So,
Yeah.
Which means the VM, the actual VM where this is running should be a Core OS. Is that what you're trying to? That's the use case you're trying to figure out.
Yeah, I mean, if you're using, if you are installing if you want to use this with OpenShift to create a lab with OpenShift, then all your hosts are Core OS.
Yes, we have to try it. I think someone did it, but I am not familiar. I will double check it.
Yeah. Okay. This is very, very impressive.
So this is great, Wim. I wanted to understand maybe a very fundamental silly question. So this one obviously is great use for labs and or POCs or CI/CD, etc. Do you think this technology can be used in production too, or?
In production, I mean, most people use, let's say, physical environments, right?
Yeah.
So in that case, so what Container Lab does is virtual wiring, right, of containers that talk to each other. That's how it is used for. So typically, it's a lab CI type of thing, but not true production, as far as I can see.
Okay.
Because we are not virtually wiring. In a real production, if you use, of course, depending what your use case is. So if you really say, my use case is an environment where you spin a set of containers that host a service for a particular customer, which is not very high throughput, but that you can do. But I'm not sure of anyone doing that with Container Lab at the moment. So typically, it's being used as for people to help doing simulations, people who are using labbing and CI pipelines. That's the typical use case.
Okay, thank you. Yeah.
Yeah, and that's what's useful for us here in SIG3.
Yeah. Yeah, so at the moment, what I did in the Ansible playbook, so during the playbook, I'm not sure whether I committed that. I'm actually installing Container Lab, and I actually do the virtual wiring like I explained. So the topology file that you saw here, I actually built from the playbooks. So they came from the playbooks itself. And so based on the input that you give, I generate them. And of course, you can build other topologies. I just wired one interface for the time being, but you could wire 3, 4, 5. Doesn't really matter. Yeah. But yeah, so that's what I wanted to.
Yeah, this is very nice. Yeah.
Yeah, thank you.
Yeah, great find.
That's excellent.
Yeah.
Definitely
did you
for
say,
all
Wim, that you started this Container Lab?
Yes, I started Container Lab. I don't know when. I think it's 3 years ago somewhere. I still remember very well. I was creating a new lab, and I said, I'm so bored of doing it again and again. I want to create a tool. So, and then I was experimenting with Go. And I said, okay, let's build it. So if you look to the first commit, it came from me. Yeah.
Oh man, we're among celebrities here.
I don't know that. I don't know that.
Oh, this is good to know. Wow, this is cool.
Yes. But at the moment, Roman is the guy that runs with it. So he was working for me at the time, and he said, "Can I run with it?" I said, "Yeah, go for it." And he does an amazing job. I mean, he built a very nice community, and yeah, he's running with it right now. So at the moment, I'm not doing so much on it, but of course, I know the insights of it. Given that I started, but yeah, so Roman is the guy that runs with it. So he did all the documentation and stuff like that. So he did a very good job of documenting all of it, keeping it up to date. So there is regular releases and stuff like that. And there is it's a Discord channel at the moment that we use.
I use my son's account.
And there is YouTube videos. So you see test clients. You can any topology. Yeah, it's very well documented, I think.
Awesome. So he's still in Nokia, Roman?
Yes, he's a Nokia person. But if you look to the contributors, they are, see, you have like various people from various companies helping out. You see?
Okay, got it.
So there's quite a few people maintaining this And you see it's regularly maintained up to, yeah. It's an active thing.
Got it. So I'm sorry, another fundamental question on this one. So you showed us some vendor specific stuff such as Arista, Cisco. What do they actually contain?
So this is the image. So basically, if the lab that I spun up, so you use here a router vendor. You could use OVS, you could use any vendor, right?
Yeah.
So they would play here. So they would, or could be used to interconnect the kind clusters.
Yeah.
Right. So I used as a Linux for the time being. It's a Nokia container image, which is free. So no license or no, so you don't even have to register to a website. So if you download, so if you look to the topology file, this one here, this image, you download for free.
Yeah.
What this image basically is a full-blown router. It supports EVPN, VXLAN, but it's not an open source, but it's open consumable. So it's a binary, it's a container image that you can use. It's full Yang support, 100%. All the telemetry is there, and it supports BGP, ISS, OSPF, VXLAN, EVPN, BGP, the whole 9 yards.
Okay.
And the same is true for the Aristas. Isosonic is in that. Sonic is there as well, right? So,
yeah, I saw that too.
So you see, there is various vendors that are in this list. You see all the Cisco, various Cisco support, Juniper support. So as I said, some of these images you can get for free, right? Without the license. Some of these images you have to register, and some of these images you have to, I think all of them you can get without really paying, right?
Yeah.
But for some you have to register before you can get access and to that image. You see?
Got it. Okay. So essentially, they're all virtual routers / switches. Yeah.
They're all containers. So, for example, Nokia SROS is actually a VM running in a container.
Got it.
So this is more heavy. This is way more heavy, but it also is. This is a lot of features are on that thing. So this is a native container image. That's also why it's so small, right? So it's like. So the whole image is 2 virtual CPUs, 2 gig of RAM. You can do the whole thing, all the BGP, all the yeah. So all of that is free, and it's very lightweight. What you see with some of the images, they are more heavy, and as a result, you consume more resources. You see?
Yeah. Yeah. Thank you. Yeah, that clarifies my question. Yeah.
Yeah. All right, so that's what I had.
So you're going to open a PR, right? So that we can look at the thing.
Yeah. So that's another question. So should we create? So now we're moving away from the One Summit stuff. Should we create another repo that is much?
So Stephen, for me, it's still One Summit. So what I did is the following. It's actually what we did in the One Summit, as far as I could tell, is basically we had a number of. Wait, so that's a different thing that I'm working on. So we had a number of, it's here. Yeah, so we had so if you look to what is happening here, right? Okay, what I did is I do install prerequisites. So for example, I deploy at the moment Docker, kubectl, so I deploy the CNIs, so the whole thing. So what I did is I added CLab to it, right? Then I deployed the clusters, right? If you deploy the clusters, what happens is, destroy. So this is deploy the cluster. So what happens is I deploy the cluster. So this is basically spinning up, depending on your inventory file, right? So so this is my inventory file that I'm using. So you can specify the amount of clusters here in that inventory file. If you say it's 2, 3, or 4, but the configuration that I built with the Ansible playbook is exactly what the Nephew POC, what we did in the One Summit. I just put an Ansible playbook around now, and then what I did. So that's the first thing that I did. And then, so for example, I can create the repos. So this is creating the repos that we need for it, and this is configure the Nefio configuration with all the CRs that are needed to set up the lab, right? So if you run to this playbook, you get basically one summit.
Yeah, I think
Okay.
it's to
So
replace
even with
what,
the one summit is a temporary repo that we put on the side. I just wonder where now we should start moving things from the one summit repo
Okay,
into
sorry.
more
Okay.
of a Nefio CI repo, and then we
Okay.
start creating so officially those artifacts are things that will run during a CI pipeline.
but we still want to actually have the Nefio One Summit lab to be tried out by folks, right? So you're saying in addition to putting it in Nefio One Summit, we want to put it in the CI/CD. That's what you're trying to say, Steve.
I don't think the repo name matters that much. It's just that do we want to change that repo into more of an official Nefio repo? It's just a name.
I thought,
I think that makes
from what
sense.
I gathered, or at least what I understood was that John probably wanted to still have the One Summit network, One Summit Nefio Summit to exist, where somebody could still go out and try it. Maybe I could be wrong here. We always wanted to do that. And what I think Wim is trying to do will be two birds with one stone, right? I mean, we can still use it for our One Summit workshop and also for your CI/CD as well.
Right. So I said that I'm not getting rid of the repo. I'm just saying that should we either rename the repo or do something.
No, we should keep it, right? Because that way, anytime.
No, keep the repo. The content
Yeah.
is obviously kept, but then I'm just saying whether or not we should be creating something that is much more officially a Nefio CI repository.
Yeah, Nefio CI officially. Okay, I see.
Which is not a bad thing. Which is not a bad thing, because at least the One Summit, I mean, if the Nefio real thing is giving you the One Summit, that's fine, right? I mean, then we can basically say the One Summit, this is the repo, how you can officially install it and use it like that. Makes sense, because then we are evolving to a true Nefio project, right? And a true Nefio thing that will be used eventually, right? Because our initial, my view is that the initial labs or the initial CI that we create is the One Summit. It's kind of the same. Maybe I'm wrong, but that's how I look at it.
No. It started off on One Summit, yes. So the repo was created to be used for that purpose. Yeah. Obviously, it's much more useful, and it's definitely not temporary. So we would like those things to be much more official. I just the repo name was not great.
So 3 months from now or 4 months from now, if one of the vendors comes in and they want to actually go try out the Nefio workshop thing, I would prefer that there is one GitHub repo that was static, where a functional one is there, and it is there, for people to try out. I would vote for the workshop contents to be static and be there for people to try out and go get familiar. And if they want to see what enhancements are happening, they will come to the Nefio CI, they'll pick that up and they'll start playing with it. Because what we have in the Nefio workshop, One Summit workshop, has got some content, some documentation, which will be fixed. But anything that we do on the CI and anything else will tend to be dynamic. They will start off from the Nefio Summit, the workshop summit, and then they'll get that, and then they'll come to our CI and to see what progress has been made.
Yeah. Okay. We can have a workshop that is basically at some point stopped.
Yes.
and then the CI would be things that would be actually be enhanced moving forward.
Yeah.
But then there'll be like 2 code base basically almost.
No, it will be one of them will be done, right? It will be frozen after some time, the workshop one.
Yeah, or the code. Yeah, the other alternative is that you basically say, here is the official one, and then you freeze. You have a version 1, which is Nefio Workshop.
Yeah, that would be much more preferred. Yeah.
Which basically is Nefio Workshop. So if you take version 1 and you do the installation, you get the workshop. You see?
Yes. Yeah,
and then you can have.
That would be much better, because now you only have 1 copy of the code. Yeah.
Indeed, yeah.
Anyway, we don't need to decide that right now.
But I create a PR for the time being, and then we can always see what we do with it, right? Yes. And I refer to the repo that I have. Yeah. It's not perfect yet. There is a few people who are trying it out. I asked some people to try it out, so which are ongoing. So there's probably a few modifications that we still have to do. Also, I did the installation remote, so whether we have to make a Vagrant file or some other files that does it locally and stuff like that. So these are all things that we have to look at. But it's a start somewhere. Yeah.
Yeah, because some of us still want to play with the VM, right? I mean, it's not done.
No.
We want the workshop VM.
Yeah, so to get to somewhere where someone can download and play with, that's definitely not there yet. So even these workshop, once someone or not, the workshop version of what we have is not completed.
Yes.
So maybe we don't spin off until get to that point.
Yes.
And then and there's still the vision of getting SMF up and all that stuff. So
yeah, we have to. I don't know. Yeah, we have to start. Yeah, but you're on holiday right now, so enjoy the holiday, Stephen. So we'll discuss when you're back. How long? How long are you gone? 1 week?
I'm back. My vacation ends on Wednesday, so I'll be back on Thursday.
Ah, right. Okay.
Yes.
I heard there was some sort of a volcano eruption in one of those national parks. Is that true? Did you get to see that, Stephen?
What corruption? Sorry.
There was a volcano eruption recently.
Yes, this is an IEC, and it has been quite mature, and it already integrated the martyrs and SILV, and also it already used the.
We are done, right, Stephen?
And call, as the lightweight ONAP, definitely there is a place they can integrate.
I think we can end this meeting, I think.
Yeah, all right.
Okay.
Thanks, guys.
Okay,
Thank you.
Okay.
Thank you.
Okay.
Yes.
Have a good one.
Looking forward to your PR and reviewing it.
Yeah, I'll
Yeah,
do.
thank you.
I'll do.
Thank you.
Thank you so much. Hey, Wim, thank you so much. Really appreciate it.
Yeah, likewise.
That was amazing. Thanks.
Yeah.
Thank you.
Hey, Tao, are you there? Guess not. I'll try you on Slack. I'm trying to get my schedule straightened up. Thank you. Bye. Thank you, Wim.
Yeah. Cheers.